Welcome to this lesson on scatter graphs, a vital tool in statistics for investigating the relationship between two different variables. In this lesson, we have three main objectives. First, we will learn how to construct a scatter graph from data. Then, we will identify different types of correlation, and finally, we will draw a line of best fit to make predictions. By the end of this video, you will be able to plot these graphs accurately, identify the type of correlation present, and use a line of best fit to make reliable predictions, just as you would be expected to do in an IGCSE extended examination. Let's start with the basics of what a scatter graph actually is. In an IGCSE exam, you are often given a table showing two sets of data for the same group of individuals. For example, look at this table showing the number of hours students spent revising and their resulting exam scores. Each pair of values represents one student and can be written as a coordinate. To construct the scatter graph, we plot these as points. Let's plot the first student who studied for 2 hours and scored 35. Notice how we use a small cross or a dot. Now we'll plot the rest. This is called bivariate data because it involves two variables. By looking at the pattern of these points, we can see if there's a relationship between how much a student revises and their performance. Once we have plotted the points, we look for a pattern. This pattern is called correlation. In your exam, you will be asked to describe the correlation shown. The first type is positive correlation. This is what we saw with our revision example. As one variable increases, the other also increases. They move in the same direction. The second type is negative correlation. Imagine a graph of car age versus car value. As the age increases, the value decreases. The points trend downwards. Finally, if the points are scattered everywhere with no clear trend, we say there is no correlation. This means the two variables are not related, like your shoe size and your math score. You might also see the words strong or weak. If the points are very close to forming a straight line, it is a strong correlation. If they are spread out but still show a general direction, it is a weak correlation. To make a scatter graph useful for predicting values, we draw a line of best fit. This is a straight line that passes through the middle of the points. When drawing this in your exam, there are two key rules to remember. First, the line must follow the general trend or gradient of the points. Second, you should aim to have a roughly equal number of points above and below the line. Notice that the line doesn't have to go through the origin, and it doesn't have to touch every point. It is an average representation of the data. We can now use this line to make predictions. Suppose we want to estimate the score of a student who revised for 7 hours. We find 7 on the x-axis, move up to the line, and then read across to the y-axis. Based on our line, we would predict a score of approximately 55 marks. This process of predicting values within the range of our data is called interpolation. Finally, let's look at a typical IGCSE exam-style question, and a common pitfall called extrapolation. In this example, we have data for ice cream sales when the temperature is between 15 and 25 degrees. The graph shows a strong positive correlation. The question asks us to use the graph to predict sales if the temperature reaches 40 degrees. If we extend our line all the way to 40 degrees, we are performing extrapolation. This means predicting a value outside the range of the original data. In an exam, you might be asked if this prediction is reliable. The answer is often no. We don't know if the trend continues. For instance, at 40 degrees, it might be so hot that people stay inside, and sales could actually drop. Always check the range of your data before trusting a prediction. You are now ready to tackle scatter graph questions in your IGCSE exams.